We have kids with us. Ahmad, you or your son attending the class?
What?
I mentioned Ahmad Muhammad, not you.
I told to Muhammad he will come.
I'm sorry.
Okay, we will start after 1 minute, inshallah.
Inshallah.
Okay, assalamu alaikum. We will start new chapter, inshallah. Before starting the chapter about our exam, inshallah, it will be written exam. So I mean handwriting exam. So you need to prepare some papers to answer the exam, and I will give you some instruction, some written instruction for the exam during this week, inshallah. You have to follow this instruction. In each answered paper, you have to write your student number and your name, and you should scan this answer in one PDF and upload it within 5 or 10 minutes. I will check which one better after the end of the exam. The exam will be around 3 to 4 questions. Of course, one question will be about ER diagram, one question will be about mapping, and one question will be about relational algebra. I will not ask you to define something, or I like to depend on understanding more. So the type of question don't need from you to memorize, it needs from you to understand more. Okay.
Sorry, doctor.
Yes.
If the questions will be on paper written, if all questions, or
Yes.
maybe yes.
No. All the questions will be written on papers.
That's maybe more one paper. How can we convert that on PDF? Maybe we can get 2 or 3 paper number base. How can we
use?
practice?
Okay. I will answer you.
Okay.
Download this application. this application and try it. You have to try it during this week, not during the exam. So try to take more than one photo using this clear scanner application, and the application will give you the opportunity to merge into PDF. Actually, when you take more than one photo, it directly consider it as PDF. Then you can share this PDF and send this PDF. Okay.
Thank you, Doctor. Okay, thank you, Doctor.
Try it as soon as possible. If you have any problem, just PM me, or you can write on our Telegram group. Okay, I will give you some instruction. It's easy application. Just try it.
Thank you, Doctor.
So until now it's 1 hour for the exam. After put the questions, if I feel it's not enough, I will give more time. So it's more, maybe 1 hour or more than 1 hour, little bit. It's depend on the length of the questions.
Doctor, that means it will be 3 questions or 4?
Almost 3 questions. If I decide to be 4, I will let you know through our Telegram group.
Okay.
Doctor,
because I did not finish, the questions not ready yet. Yes. So.
Okay, Doctor. But yeah, please, we trust you. Try to make balance between timing and question.
Inshallah, there will be
enough time. Because it's takes more time for your diagram, for mapping.
Okay, another issue. You have to open your camera during the exam. When you finish the exam, also you have to stay in front of the camera. So you finish the exam only when the time finish. Okay.
No problem. But
okay, Doctor,
during the exam,
problem.
could I open my lecture note?
It's up to you.
It is regular. Okay, no problem for you. If I want to see some note that I write down while I am studying, it is okay. No problem.
I cannot force you not to do.
Okay, Doctor. Thank you very much.
So actually, when we made the exam online, we understand that it's almost open book exam. But the issue, it's about not sharing with others. So that's why the time should be exactly enough, not more than enough. I mean, I cannot give you more time if the exam can be answered within 1 hour. So if you want to search in the book or not, this will take time from you.
Yes.
So you need to study before.
Of course.
Okay. Because the exam is not about memorizing the information, so it doesn't matter for me if you have the book or not having the book, because it's depend on your understanding. Okay.
Okay, Doctor.
Anyway,
Doctor,
any two identical answer, okay, will be 0. To be no.
What?
Okay, Doctor. Thank you.
I mean,
sorry, Doctor.
You should not share your answer with others in any way. So it should
I have a
be
question.
clear. This no need to mention this for you, but just to remind you. Okay, let us don't lose more time and continue. Do you have
just 1 minute,
any?
Doctor. 1 minute, please,
Okay.
Doctor. Just 1 minute. Are there in exam MCQ or details written numeration, any that's detail about questions? Are there include with the exam maybe some MCQ about our topics, or just mapping and ER model?
I answered you. There's no question about memorization. I mean, you have one question for mapping, for ER diagram. It's depend on your understanding. I will not ask you to define anything or make comparison. Okay? So ER diagram, mapping, and relational algebra. Until now, if I have anything else, I will let you know during these 2 days, inshallah.
It's clear, very thank, Doctor.
Okay, I think it's clear. About the student who asked me for more more examples for join and selection, I will try my best to make a video for you to give some examples, but I cannot give extra lecture because we need this lecture for our topic today, for our new chapter. So I cannot give extra lecture to make some review. I will make my best to make a video and send to our Telegram group, inshallah. Okay, now we continue.
Okay.
Okay, should be interesting topic today. It's about functional dependencies and normalization for relational model. As I mentioned before, to get good database without any problem, you have to follow some steps. Okay, and I said after collecting the data, okay, you need to get ER diagram from the description of the data. Then you make mapping from this ER diagram to get the relational model. Then this relational model, you should follow some guideline and make something that we call normalization to show that it's normal form. This means it don't have any problem. We call this problem anomalies. Okay, so you need here to make normalization. Actually, we have here in normalization, we will speak about the normalization. We have around 6 normal form or 6 step for normalization. We will speak about 4 normalization: first normal form, second normal form, third, and BCNF. Actually, fourth normal form and fifth normal form in chapter 15, now we are in chapter 14, it's very, very rare. Even BCNF, almost you will not find problem with BCNF for most relational model. So I think no need to waste our time in fourth and fifth normal form, and it's very rare to happen. Okay. So in this lecture, we will speak about some guideline for good relational design, and then we will discuss functional dependencies and normal forms from first normal form until BCNF. Okay. However, if you follow the algorithm for mapping from ER diagram to relational model correctly, almost you will not find any problem with normalization. So if you design your ER diagram correctly and map it correctly following the algorithm to relational model, you will not find problem with normalization. Okay, what guideline we have? First guideline, your schema, your relational model should be easy to understand, easy to explain. If I look to your relational schema, I should understand the relation inside it and everything. To do this, you should not combine attributes from multiple entity type or relationship type. So if you map your ER diagram to relational model correctly, you will not have like this combination between more than one entity type, because when we map each entity type to relation, and some relationship also will be mapped to relation, single relation. So this guideline, if you follow the correct procedure, the correct algorithm for mapping, you will not have this type of problem, except if you make some merging. Actually, these two examples for violating guideline 1, it's come from join between more than one entity. For example, this violating guideline 1, because we have information about employee here, this information, and department. This information come from entity department. That's why we have problem with or violating guideline 1, that we should not combine between multiple entity. This one's the same. We merge between employee and a project. Okay. What will happen when we merge? Okay, here not clear. Okay, what's the problem? But you can see the problem here when we have data, that we have redundant or redundancy in the data. This redundant data or repeated data, you can see here many of this data repeated. You look here. Okay, this come from the join, because when you make join, you get tuples from one relation and from two relation and make them in one relation. So sometimes you will make some redundancy in the data. This redundancy in the data or violating this guideline 1 will cause two problems. First problem, waste of storage, because you can, instead, for example, of repeating this information of a project with all employees, then when you have two relation, not one relation, then information for project will not repeat it, only one table for each project. But for this repeating or this redundancy, you are wasting the storage. This first problem. Second problem, you will have, or this will cause problem with update. We call this problem update anomalies. Okay. This three types for update anomalies: insert, delete, and modification anomalies. Okay, what's the insert anomalies? When you try to insert data, there's inability to okay, sometimes let me give the examples here directly. Okay, this example, I don't like to describe things without information in front of you. So this relation have problem. It's violating guideline 1. So sometimes we cannot insert here. We have project, we have employee. So to insert a project, you have to insert employee information. To insert employee information, you have to insert a project information. So I have, for example, a new employee. I want to add this new employee. It's not appointed to any project. So I could not do this. Why? Because if I want to insert the employee, I have to insert the project for him. I have to insert all this one. Because the project number cannot, and the employee number key cannot be null. So here I cannot insert some information because there is related information with it. Sometimes I cannot insert information, inability to add data to database. Why? Because absence of other data. Like here, I cannot insert a project unless an employee is assigned to it. Of course, the solution, some student will if you insert null, this will violate this okay, entity integrity. So you will have violate entity integrity. You have problem with entity integrity. What's the entity integrity? Key cannot be null. Sorry?
Sorry, doctor, I can't hear you. About me or
you
or other student. Same.
Is there anyone cannot hear except Ahmad?
Yes, doctor.
Yes, Dr. Me.
You cannot hear me.
Yes,
Then
doctor.
how you answer?
Doctor, your voice is how we can say it متقطع. Come on.
Hey,
Clear, not
Okay,
clear.
okay.
secret.
Voice is
Okay,
out.
okay. You cannot hear me then. Wait, let me check the problem. Maybe
Yes.
it's internet
Yes.
problem. Just a moment. Okay, Assalamu alaikum again. Hopefully now you can hear me.
Yes, it's okay,
Yes,
doctor.
Yes,
now it's
doctor.
better.
Now it's good.
Is it clear now?
I hope.
It's clear.
Yes,
Yes,
doctor.
yes, better, doctor.
Yes, doctor, it's clear.
Okay. My actually, all my kids are playing at the same time on the internet, so this is a problem. Okay.
It's okay, doctor.
About insertion anomalies, when you try to add some data and you cannot add this data because the related data or there is some absence of the data. I give you here example. When we have like this relation, it have problem because we have information about employee merged with tables or attributes from a project. So we have two entities merged in one relation. Here we cannot insert a project unless we have employee assigned to this project. So here's a problem. Some data, for example, project data, we cannot insert because there is no employee until now assigned to the project. It's reasoning when you get a new project, you did not assign until now any employee. You need to add this information first. You cannot add this information or insert this information. Here's the problem. Of course, the opposite also true. You cannot insert employee unless you have the project that he or she assigned to it. What about if some of employees not working in a project? You cannot add their information. What about if some employee, new employee, not assigned yet to any project? You cannot also add their information because you volatile here guideline 1. Also same thing for delete. When you are, for example, or when you want to delete, for example, a project, then you will delete all employees that working on this project. Or, for example, if you have one employee and you want to delete this employee moved, or you want to delete his information. So deleting this employee will result on in deleting the project. So this delete anomaly. When you are delete unwanted information, this will cause deleting needed information. For modification, it happens when you have this redundant data that when you want to modify one of this redundant data, you have to change everything. But if you forget to update or change everything correct, you forget some data, some data update it incorrectly, then this modification anomalies happen. I will give example here also. Same example. If you want, for example, to change project number 1 name from product X to product L, then you have to update all the tables of the employees that have this project. Otherwise, if you update, for example, wrongly for some tables you forget to update, okay, this will cause problems. This data will be inconsistent. You will have project, for example, 1 with some employee name product L, and for other employee it is you forget to update, it will stay product X for the same project. So here's the update, a problem happen. Guideline 2. You should design your schema that not suffer from insertion, deletion, update anomalies. If there is any anomalies, you have to take consideration during the application. It's better not to have this problem, but if you have this problem, you have to take it into consideration during the application. It's not our job as database engineering to do this in the applications, so it's better to design it well. So first guideline, it's about the for not to mixing between these two guidelines. Here, do not combine attributes, okay, from multiple entity or relationship. Guideline 2, it's about to design the schema that does not suffer from insertion, deletion, and update anomalies. Guideline 3, it's about null values. You have to design your relational schema or relational database to have as few null values as possible. To do this, if you have some attributes that could have null frequently, you could separate it in another relation with, I will give example, with the primary key. So sometimes in tables you have, for example, relation like this, and you have attribute X. This attribute X most time null for the tables. So you need to take the primary key, copy from it, and you take this out in another relation. Here, one example for null value guideline. For example, if you have 10% of your employee with phone number, then if you have this relation information about the employee and office phone. This poor design. Why poor design? Because in this relation, 90% of the phone number attribute will be null. Then most values will be null here. What's the solution? The solution, this employee relation could be divided into two. First relation will have all the information of the employee except the attribute with null value every time, most the time. And the second one will be this attribute with the SSN or the primary key. So we take copy from the primary key and we take out this one from the original relation. Now you will have only information when you have phone number. You will not have null values for the phone number. Okay. We have here a problem called spurious table, or let me, if I want to use some common language or slang language, we can make it, we can name it like fake tuples or tuples that it's not or it's not correct, it's fake. Like what? This tuple. It's actually come from if you have bad join operation after decomposition, you have like this one relation. Let me show here the example. You have one relation, and after decomposition for the relation, when you join it again, look to the original relation and the new relation. You will find that this tuple, these two tuples, it's not in the original one. It's actually come from problem with the decomposition and join. This type of tuples, we called it spurious tuples or fake tuples. Okay. So bad design for the relational database may result in this problem, spurious tuple. And you have to avoid this problem. To avoid this problem, we do operation called lossless join. We will take it during this chapter, inshallah. In this lossless join, you apply a procedure that when you make decomposition for one relation, to be sure that when you will, when in the future you will do any join, it will not suffer from this spurious tuple. So, guideline 4 said, design relation schema so that they cannot be naturally joined on attributes that are partially related. For example, here, okay, natural join on attributes that are partially related to primary key, foreign key, in a way that guarantees that no spurious tuples. In short, the relations should be designed to satisfy loseless join condition. Actually, loseless join condition, we will speak about it as a procedure later. So keep this guideline for until we reach that area. But I will mention the loseless join here. You see here, it's not depending on loseless join probability. This one depending on it. So when we do decompose this AB here and AC here, the result when we make join, we have superior tuples. But here do not have superior tuples. So loseless join probability will help us to avoid this superior tuples. So guideline for you have to make the relation or to design the relation to satisfy this loseless join condition. Later we will take a procedure how to make sure that our relation satisfies this condition. So this summary for the guideline: do not combine attribute from multiple entities. Design the schema that does not suffer from insertion, deletion, and update anomalies. This means no redundancy should be. Okay. Guideline 3 relations should be designed such that their tuple will have as few null values as possible. We don't need too much null values. Guideline for the relations should be designed to satisfy loseless join condition. Actually, it's long to speak about loseless join condition here. So let us delay it until it's time because need some examples. Okay, functional dependencies. Okay, when, for example, a set of attribute X determines a set of attribute Y, this means X or Y functionally dependent on X. It means that each value of X determines only one or a unique value of Y. So if X determines Y, this means each value from X will give you a unique value from Y, not the opposite, okay? Because Y is functionally dependent on X. So X determines Y, Y functionally dependent on X. So the value of Y, of X, sorry, determines the value of Y. If I give you that X1, then you will find only one value depending on it, or it will determine one value. For example, project number 1, its name X, Y, Z. In any place you find this one, you will find you can get Y. Okay. This functional dependency, we use it to measure the goodness of the relation design. So to measure this goodness of relation design, we should sure that this relation is in the normal form. This normal form have some levels. First normal form, second, third, BCNF, fourth, and fifth normal form. We will speak about condition for each normal form, and you will see that all the normal forms speak about the functional dependency. Okay, this is another definition for functional dependency. So if you find x in tuple 1 equal x in tuple 2, this means y in tuple 1 will equal y in tuple 2. So if you have like this, x and y, and x determine y, this means any value here for x equals the value of x here, it will have same value for y, because x determine y. This is the formal definition for functional dependency. This functional dependency can be defined on the relational model like this. Let me, where's example? I think we have draw here. Okay. Like here. This functional dependency means SSN determines birth date, address, department number, employee number. So we can write it like this. SSN determines birth date, address, and blah blah. Department number determines department name and department manager SSN. So here the functional dependency like this. We draw it in the relational model. Okay, some examples for functional dependencies here. Okay, that social security number can determines employee name. Project number can determines project name and project location. Could be like this: social security number and project number, both of them determines hours. Okay, I think functional dependency it's very clear now. Okay, what functional dependencies here? Maybe one of you can try to find functional dependency. I will ask you, do we have, for example, A can determine B? To answer this question, you will check two values of A, two similar values of A. If have same value for B, then it determines A1, A2 have B1, sorry, A1, A1 have B1, B2. So no such functional dependency. Okay, let's check the opposite. Does B1 determines A, B, sorry, determines A, you will try to find, okay, we have here B2, B2, it have different values, so it do not determine. C, you can find that C2 here, it determines B, because C2 it's have B2 here. Okay, so we can say that C determines B. Does B determine C? Yes, also.
Yes.
It could be no. Okay, but here, yes. Do we have another thing? Okay, maybe we can take a look for D. It's not determines. C, it's not determines. Because we have here D3, different. Okay, what about take A and B, like this, A and B. If you take A and B, it determines C and it determines D also. Why? Because take any A, any two, we don't have any repeated values, so it can determine, it could determine this. So it's depend on, actually it's difficult, you can check it from this data, but it's not the complete data, it's not the complete information. So we said it may exist, but not sure it exists. So A, B can determine C and can determine D. It may exist, but I don't have enough information here. Maybe if I continue data here, I will find it's not determined. Maybe if I have description for this database, I will find it not determined. So like this, we can check if we have data, but it's better if you have understand for the system from the beginning. So this could be here. B could determine C, C could determine B, and AB, as I mentioned, could determine C and could determine D. Also CD could determine B. That's for this one. Okay, what about normalization? Let's start for the normalization. What's the meaning of normalization? Actually, normalization, this meaning decomposing or cut the relation, okay, that have a problem, decomposing bad relation, unsatisfactory relations, and breaking it up into smaller relation. Okay, this is a normalization. Then when we have one relation that have problem, we want to decompose it maybe to one relation or to two relation or three relations. We depend on this about some procedure and some condition depending on the keys and depending on the functional dependencies. So, normal form to do this normalization using keys and functional dependency of a relation to certify whether this schema, this relation, in a particular normal form. If not in this particular normal form, this means it's bad relation and we have to make normalization. Okay, as I mentioned, usually normalization up to third normal form or BCNF. Fourth normal form and above, it's very rare to use in practical use. So this, I think this information about keys, we already mentioned it before 2 chapters. I think before 3 lectures. We speak about super key. We mentioned that super key, it's a set of attributes that identify or uniquely identify this tuple in the relation. Okay, and key is the minimal super key. And when you have more than one key, each key considered candidate key. And then we can take one key as a primary key from this candidate key. Other keys, we call them secondary keys. So we have super key. Super key, as we know before, a set of attributes that no tuples can identify this tuple in the relation. So no tuple have the same value for this super key. This super key, if we can remove some attribute from it and it's still unique, it's still identify tuples in this relation until we reach the minimal super key, this become key. Sometimes you have more than one key. Each key is a candidate key. So, for example, if I have key 1, key 2, key 3, each one candidate key. If I choose one of this key, I will choose one of this key as a primary key, one of the candidate key. The remaining key, we call them secondary key or secondary keys. Okay. We want from all this to reach this two definition, prime attribute and non-prime attribute. In short, any attribute that member or part from candidate key, not only primary key, any candidate key, because key could be more than one attribute. So, for example, if key 1 have attribute A1, A2, then A1 a prime attribute, A2 also a prime attribute. So attributes that member of some candidate key consider a prime attribute. We should know this because we need this in some normal form. Non-prime attribute, any other attributes that not prime, consider non-prime attribute. So attributes that part from the key, prime attribute. Attributes that not part from any key, it's non-prime attribute. Okay, this all definitions that needed for the normalization. The keys, the functional dependencies. Okay, we need this information here for normalization. We start now for the first normal form. Actually, first normal form, this any relation consider in the formal form if and only if domain of each attribute contains only atomic value. And I mentioned before that what the meaning of atomic value or individual value. So if you have composite attribute, this volatile the first normal form. If you have multi-valued attribute, this also problem and disallowed in the first normal form. If you have nested relation that have non-atomic value, I will give example for this nested relation. Also, this mean your relation not in the normal form. Then what's the solution to make it in the first normal form? If you have composite attribute, the first or the best solution to separate this to simple attribute. So if you have, for example, name and name have first name, mid name, then you can use directly the first name, mid name, and last name. Actually, we mentioned this during the mapping. So if you do mapping correctly, you will not suffer from this problem with the first normal form. Multi-valued attribute, you need to create a new relation, take this multi-valued attribute, plus copy from the original primary key. This is the best solution. You have around 3 solutions to solve multi-valued attribute. We will speak about those solutions. Nested relation, it's similar to multi-valued attribute. Actually, nested relation, when you have multi-valued and at the same time composite, it's come from bringing one relation inside another relation. So this new relation that come inside another relation, it's contains some attributes, and this attributes value will be multi-valued. So you will have problem here. I will give example. Any DBMS will allow only relation that have or that satisfied first normal form. If you not satisfy first normal form, the relational DBMS will not allow this type of relations. Okay, this example, we have D-location. It's a multi-valued attribute like this. One solution, it's to make the attributes, separate the attributes like this. But here, you look department number, it's the primary key. When you repeat this with all the data here, so you will have repeat value in this department number, for example. To solve this issue, then this multi-valued attribute will be part from the primary key. So the original primary key plus the multi-valued attribute after make it as a simple attribute will be the new primary key. Actually, this one of the worst solution in my point of view. Why? Because it's not follow the guideline number 2. Here we have redundant data. So it's not the best solution. To make this like this multi-valued attribute, make it simple attribute, and take it with the primary key as a new primary key, it's not the best solution. Actually, it's not good solution, but later I think in more normal forms, it will be solved. So, what techniques or solution for this type of multi-valued attribute? We have three solutions, three main techniques to achieve first normal form, especially when we speak about multi-valued attribute or nested relation. If we speak about composite attribute, the simplest way is to make it simple attribute. Just to remove the composite, make it simple, like the name. You take first name, mid name, last name, and finish. Okay. Then, first technique said to make this, for example, here, in the first normal form, we will separate this multi-valued attribute in a separate relation like this here, a plus along with the primary key. Here in this example, department number. So this relation does not exist anymore. It's become into two relations. The original relation plus new relation that contain the multi-valued attribute with the primary, with the copy of the primary key. So this foreign key and this is original primary key, and both will be as a primary key. Okay, then this best technique. Then this technique, another time, you divide this relation into two relations. One relation have the composite attribute, it will be taken from the original relation, a plus copy from the primary key. And the remaining attribute will be in the original one. So two relations. Okay. The next technique, or technique number 2, that the primary key become combination between the original key and multi-valued attribute, like this solution. And I mentioned, when you make this composite attribute like this, become primary key with the original primary key, you will have a problem. It's not the best solution. You will have here problem with or disadvantage with redundancy in the data. And because this, it's rarely adopted, this solution, rarely used. The best solution, it's number 1 actually, but I give you information about other solution or solutions. Okay, third solution, it's only if you have or if you know number of redundant data, or this attribute will be how many times it will be redundant. If you know that department location, it's maximum, for example, 3 locations or 2 locations. So you can separate it into department location 1, department location 2, department location 3. So this one, for example, it will be like this. It will be like this. Same one. Let me draw it here. This delocation will become like this. Location 1, 2, and location 3. So this one have 3 location. sorry. Okay, and so and host, and this one Starford, and this one Houston, and this one null, and this one null, and this one null, this one null. Then this is the third way or third technique. Why third technique, not the best technique? Any answer here? Because this technique, volatile, the guideline number 2, we have too many null information here, too many null data. This is a problem. So first technique will be the optimal solution for multi-valued attribute to become in first normal form. And second technique have problem with redundancy. And third technique have disadvantage for null value, which will volatile the second guideline, and you have too many null value here. Okay, this just to see the nested relation. Here we have nested relation because this relation, which project, it's come as a part with the employee, but you can see for each employee, you have redundant for the project data. So it's multi-valued here, multi-valued, and here it's composite. So it's composite and multi-valued. So the best solution will be to take this one in a relation a plus the primary key. And what's a new primary key? So we should divide this one to become in the normal form. We will divide this one into 2 relations. We will take the nested relation, which is P number, and hours, with a copy of the primary key, which is SSN. Okay, and what remain in the original one? Remain SSN and E name. Primary key for original one, it's the same. What's the primary key here? When you have like this nested relation, you have a partial key. Here we have a partial key, which is B number. you look here, it's uniquely identified when composite or when be added to the primary key. So it's partial key. It's not repeated with any of this primary key. So the new primary key here will be the original primary key plus the partial key. Actually, another time I will mention it more and more. If you mapping correctly, you will not have problem with the first normal form. Even with the second normal form, you will not have problem. Even with any normal form, you will not have any problem. Okay. Here's the another example for the nested relation that it's not in the normal form. Why? Because we have this relation, as you can see, we have here multi-valued attribute. This, when you use this inside the relation, this means multi-valued attribute. This is the end of it. And even it's nested with multi-valued attribute, and it's also composite. You can see 1, 2, and this one also part from job hist. And it's also composite and multi-valued attribute, cell head. Then, what's the solution? We will divide it into 1 and 2, and the original one. So this with this one relation, 2 relation, 3 relation. So the original one have SSN with the name. This first relation. Second relation, which is job history. Okay, it have company as a partial key. Here you can see it. Sorry, I just covered it. Here I mentioned a partial key as dots under it. So we have company as a partial key plus copy from SSN. So both will be the primary key. What else we have? Highest position. Okay, this second relation. Third relation will be, or relation 1, this second one, 3, 1, 2. Okay, this is the inside one, sales or sale salary history. It have year as a partial key, and what is its parent or owner? It's owner for sale history, job history. What's the primary key for job history? SSN and company. So it will take copy from SSN and company, and you will have also year as a partial key, then primary key, all this one. What remain here? Max salary. So like this, we can make the first normal form for the nested relation. Okay, second normal form. Second normal form use the functional dependency and primary key in the definition. So we need some definitions here. What is the prime attribute? As I mentioned before, prime attribute an attribute that is member of the primary key or candidate key. Okay, so if you have attributes that member from primary key or member from candidate key, it's a prime attribute. Okay, another definition that it's important definition for the second normal form, full functional dependency. If we have dependency y and z, y determines z, it's full functional dependency if removal of any attribute from y means this functional dependency not exist anymore. I can mention it in another way. This means part from y, any attribute from y cannot determine z. Okay, for example, if y have attribute a1, a2, and we mentioned that y determines z, it will be full functional dependency if a1 cannot determine z and a2 cannot determine z. If I have any attribute from y that can determine z, then it's not full functional dependency. It becomes something that we called it partial dependency. Okay, then we have now the definition for full functional dependency that if we have y determines z, then remove any part, any attribute from y means that this functional dependency not exist or not hold. In another way, this means that part of y cannot determine z, or attribute from y cannot determine z. If you have part from y determines z, then it becomes partial dependency. This example, one example for full functional dependency and one example for not full or partial dependency. We have social security number and project number. It's determine hours. So if we have information, employee number and project number, we can know how many hours he worked for this project. But we don't have social security number. Cannot, if I said social security number, it's not determines hours. Project number, it's not determines hours because project number, okay, hours for which employee? If I have social security number of the employee, okay, for which project number? So SSN determines hours, nor project number determines hour not hold. Either nor, this mean it's not hold. Okay, this mean when you have this parts not hold, this mean only when you have the whole y, the whole functional dependency, this mean full functional dependency. Okay. Also, if I have social security number with the project number, I can give you the employee name. But this one, not full functional dependency. It's partial dependency. Why? Because social security number can determine employee name. It's holds a functional dependency. So it's part, you see, this part, then it's partial dependency. What about the normalization, second normal form? Second normal form, the relation R is in the second normal form if every non-prime attribute in the relation is fully functionally dependent on the primary key or on every key, because sometimes it's not functional dependence on only the primary key. So I will give you example here. If I have this relation, I have primary key, part 1 and primary key part 2. Okay. And if I have candidate key, and I have attribute X or attribute A. Okay. If every non-prime attribute, like A, candidate key here, it's a prime attribute. What's the definition of a prime attribute? An attribute that is a member of the primary key or candidate key. So this is prime attribute, this is prime attribute, this is prime attribute, a not prime attribute or non-prime. Every non-prime attribute in the relation is fully functional dependent on the primary key. So it's like this. If we have the primary key fully determine this attribute, this means every non-prime attribute fully functional dependence on primary key or on every key. It could be like this. I will give examples for this. Anyway, to any non-prime attribute should be full functional dependence on the key, especially the primary key. But if it's also full functional dependent on candidate key, also it's okay. It will be in the second normal form. So if I have a relation that not in the second normal form, what's the solution? To reach second normal form, we have to separate any partial dependency into a new relation. So this partial dependency, if you have here, no, I don't have. Okay, if I have here example, I will give it. If you have any partial dependency, you will divide it or separate it in new relation. Let's check this dependency. This one, FD1, is it partial or full dependency? I need answer. If no answer, it's better to stop speaking.
It's a partial.
Sorry? It's a full. Why it's a full? Because I can, as you can see, we have primary key here, and the whole primary key determine hours. So it's full functional dependency. Okay, FD2, is it a partial or full? Any answer? It's a partial functional dependency. Why it's a partial functional dependency? Now I think you you missed something during the definition, but from this figure you should know, because this functional dependency means employee name depend on or functional dependent on only part from the key, partial of the key. So SSN determines E name. And I said that SSN plus project number, it's the primary key. So this non-prime attribute depend on part from the primary key. If any attribute depend on part from the primary key, then it's partially dependency. This one, FD3, is it partial or full?
It's partial.
Yes, it's partial. Why? Because B name and B location depend on project number, which is part from the primary key. So it's now easy to understand which one the partial, which one the full. If the attribute depend on the whole key, then of the key, then it's partial. Okay. In the second normal form, we don't need the partial dependency. We don't need any attribute depend on part from the key. So what's the solution? Each partial dependency will be separate in a new entity. So we will have a new entity for this partial dependency, let's say E1, and a new entity for this partial dependency, sorry, this one. Not to confuse, I will move it. Okay. So we have full functional dependency, partial functional dependency, and partial. This partial dependency, we will separate it in relations. This partial, we will separate it in the relation. And what remain will be in the original one. Let's say it's this one, B name, B location, B name, B location, with a copy of from the primary key. Okay, then we finish this too. This one, E name, with copy from SSN. Then we separate the functional dependency here. Okay, what remain here? We have hours with the original primary key, which is B number, SSN number. The part from the primary key that you take in the new relation will be the new primary key. Okay, so for this functional dependency, this part B number will be the primary key. For this functional dependency FD2, the SSN will be the new primary key. I think It's direct and simple, the second normal form. Okay, then this another example for the second normal form. FD1, is it full or partial? FD1.
It's full. It's full.
Full. Okay. FD2, is it full or partial?
Partial.
No, it's full. Why it's full? You have to focus. This candidate key. So we have two keys. Key 1, it's the primary key. Key 2, it's the candidate key. Okay. What's the definition for third normal form? If we have any, here's the definition. Every non-prime attribute is fully functionally dependent on not only primary key, also in any key or every key. Okay. So we have this key and this dependence on the whole candidate key. So it's full functional dependence, but it's full functional dependent on the candidate key. This full functional dependent on the primary key. Because this attributes, as you can see, you will ask yourself, okay, this attribute depend on the whole key, the whole candidate key, or part from it? The whole candidate key. So it's full. For also this attribute, the whole, for this, the whole candidate key. For this, the entire or whole candidate key. So this full dependency. What about FD3? FD3, it's a partial. Why it's a partial? Because tax rate, as you can see, depend on only country name, which is part from the candidate key. Okay. I will ask another question. FD4, is it partial or full?
It's partial, Doctor.
It's not full and not partial. Actually, we did not speak about this type. Why? Why it's not full and not partial? Because the relation was not, it's here, this functional dependency. Area determine price. Area, not a key. So because area not a key, we cannot say that a price depends on part of the key or the full of the key. Actually, this, it's named transit, or it's like transit, yes? There is something or key determine area, and area determine price. Later we will speak about this transit dependency. So, but it's not partial or non-prime attribute that partially depend on a key. It's not partially depend on the key, yes? So we don't have any job with this functional dependency form. and we don't have problem with normalization in FD1, FD2. So the problem only with FD3. Do you have any question?
Yes, about FD4. Is it in the third normal form or in the second normal form?
We will speak about it in the third normal form. So
FD4.
we still now in the second normal form.
It's in the third normal form because it's non-partial or and non-form.
Yes, we will speak about this type of functional dependency in the third normal form.
Okay.
Okay, so it's not dependent on any key. So we speak here in the definition, it's very clear. Every non-prime attribute should be fully functional dependent on the key, on primary key or on candidate key. If not, then it's partially dependent on the key. If it's partially dependent on the key, like FD3, then we have problem. Problem in the normalization, then we separate it. Then we will take this one, because this one, FD3, it's partial. We will separate it. We will take tax rate with the copy from the key, which is country name, and it becomes a primary key. What remain here? We remain here the property ID, the country name, because we only take a copy here. This one we take it. So lot number, area, and price. And you have to keep the functional dependency. We have this FD1, FD2, FD4, FD3 come here because it has a problem with the second normal form. So if you have any functional dependencies that have problem with the second normal form, it's partial dependency, not full dependency on the key, This is important. Then we separate it in another relation. Okay, we come here to the third normal form. We have a transitive functional dependency. If you have X determines Z, okay, and through Y, this means if you have X determine Y and Z and Y determines Z, then we have X determines Z as a transitive functional dependency. So functional dependency, X determines Z, it's a transitive functional dependency if we have X determine Y and Y determine Z. Example here, social security number can give me his manager, department manager, but it's not directly. You will have the department number first, then from department number, it's identifies a department manager SSN. So this functional dependency come from its original that SSN determine D number and D number determine manager SSN. So this functional dependency called transitive or transit functional dependency. But for example, SSN as a primary key determine employee name directly, this non-transitive Okay. What about third normal form? A relation will be in the third normal form if it's in the second normal form. By the way, normalization, each level depends on the previous one. So you cannot start second normal form if it's not on the first normal form. So each normalization have two conditions. First condition, the relation should be in the previous normal form. Second condition, the condition of the normal form itself. So condition for second normal form, it should be in the first normal form, and it should hold the or should satisfy the condition of the second normal form. For the third normal form, the relation also should be in the first normal form and no non-prime attribute transitively dependent on a primary key or candidate key. When I write primary key, make it general and candidate key. So if we have in the relation any non-prime attribute just 1 second, let me answer this one. Okay, let's take the third normal form and stop, and we can continue later. Okay, like we mentioned before, the third normal form also it's about the key, primary key or candidate key. So if we have any attribute that transitively dependent on the primary key or candidate key, then this relation not in the normal form. So we should not have this type of transitive dependence. What to do? We will separate this transitively dependent functional dependency in a new relation. So the condition here, second normal form, and no non-prime attribute transitively dependent on the key. Okay, here, if we have like this relation, functional dependency, X determine Y, Y determine Z, and X is a primary key or a candidate key, then this problem only if Y is not a candidate key, because if Y only it's non-prime. What about if Y prime? If Y prime, then it's not a problem with the third normal form. So if we have a transitive dependent, transitive functional dependency, but through a candidate key, it's not a problem. The problem if this transitive dependent comes from non-prime. Non-prime, it's mean not apart from a key. Okay, So, in this example, we continue. In this example, we have employee department. As you can see, we have SSN as a primary key, and we have FD1 and FD2. Is it first normal form? Yes. Because we don't have any composite attribute, we don't have any multi-valued attribute. Is it second normal form? Yes, because this one, full functional dependency. This one, it's not full or partial, it's a transit. Is it third normal form? No. Why? Because we have here, you look, SSN, determine number, number determine this two. Then X determine Y, Y determine Z. Y, which one Y? Here, this one. Department number. Is it a candidate key? Is it a primary key? No. Then it's not satisfy the third normal form. What's the solution? This functional dependency will be separated like this. Department SSN, D manager SSN, D name. This attribute that in the middle here, X determine Y, Y determine Z. Okay, we will separate this. This attribute in the middle will be the primary key, and we take only copy from it. So as you can see here, the solution, we take this one and copy from this one as a primary key here. So what remain in the original one? Employee name, SSN number, birth date, address, and the number. Okay, this is another example for the second and third normal form. Let's check. Okay, is it full, partial, or transit? Now I ask three types. This one, FD1, full, partial, or transit, or transitive. You check all attributes depend on its a key, not part from the key, so it's full. Functional dependency. FD2, is it full or partial? It's also full functional dependency. Why? Because country name and lot number, it's a candidate key, and this attribute depend on the whole candidate key, not part from the candidate key. FD3, is it full, partial, or transitive?
Partial.
Yes, it's partial dependency. FD4, is it full, partial, or transitive?
None for, not partial.
It's transitive dependency. Yes. Why? When you see like this, non-primary or non-key attribute determine another attribute, then you will understand that it's transitive. Okay? So what's the solution? The solution, it's come from one normal form to normal form. It should be sequential. Third normal form. So before reach 2, we have to reach 1. It's okay, it's in one normal form. It's in first normal form because we don't have multi-valued or composite. Okay, is it in second? No, because we have partial. So we should solve this problem before reach third. How to solve it? We will separate it. This functional dependency, tax and country. Okay, and country become primary key. The remain we will take it here. Okay, now it's this one. It's in the second normal form. But the answer, the question here, is it in the third normal form? No. Why? Because we have FD4, it's a transitive dependency. What's the solution? We separate this transitive dependency. Then we take price here and area become primary key. Then what remain here? Area, lot number, country name, and property number. Now this one in the third normal form. So first normal form, all attribute depend on the key, or we don't have multi-valued or composite attribute. Second normal form, the attribute depend on the whole key, then no partial dependency. Third normal form, the attributes depend on nothing but the key. If you have attribute depend on anything except the key, any other attribute, then it's not in the third normal form. Okay, we continue inshallah next lecture. I have to finish here. We still have BCNF and some other examples, and also full example about normalization like this. We have many examples here. We will continue inshallah next lecture with normalization.
This lecture is included in the exam.
Please, I have a question.
Yes.
Doctor,
Yes.
Is that lecture will enter to midterm?
I think we cannot take lecture next week, but we will have a catch-up lecture.
No, Doctor,
Okay.
we mean that this subject will be responsible